Now we will see the topic is cluster analysis. So in the previous videos we discussed the machine learning types and the support vector machines. The SVM is used for the supervised learning techniques for classification purpose. Now we will see the cluster analysis. It is used for the unsupervised learning techniques. First one is the outline. Cluster analysis overview, statistics associated with cluster analysis, then classification of clustering. Next one is the one type of clustering, that is the hierarchical clustering types. So first we see the cluster analysis. Here used to classify objects or cases into homogeneous groups are called clusters. So objects in each cluster tend to be similar and dissimilar to objects in the other clusters. So both cluster analysis and discriminant analysis are concerned with classifications. These requires prior knowledge of group memberships. In cluster analysis, groups are suggested by the data. It is an ideal clustering situation. Here we have considered two variables dataset, variable 1 and variable 2. So we have consist of four clusters, cluster 1, 2, 3 and 4. So these data are grouped based on the future similarities from the total dataset. So more common clustering situations, here we mentioned the number of datasets, it will convert to the some group of clusterings. The next one, statistics associated with the cluster analysis. First one, agglomeration schedule. Here gives information on the objects being combined at each stage of hierarchical clustering process. The second one, cluster centroid. Here, mean values of the variables for all the cases in a particular cluster. The third, cluster centers. At initial starting point in the non-hierarchical clustering, the clusters are built around the centers or seeds. The last one, cluster membership, indicates the cluster to which each object or each case belongs. So this is four processes in the statistic associated with the cluster analysis. The continuation, here the dendrogram is the tree graph. A graphical device for displaying clustering result. The final clustering result is represented by the tree graph. The distance between cluster centers, this distance indicates how separated the individual pairs of clusters. Then clusters that are widely separated are distinct and therefore desirable. The next one, Icicle diagram. It's another type of graphical display of clustering results. So here the two way the clustering result is represented. One is the icicle graph, another is the dendrogram. In dendrogram, the vertical lines represent clusters that are joined together. Next, the position of the line on the scale indicates distance at which clusters were joined. The next one, conducting the cluster analysis. Here we follow the some steps. Formulate the problem, select the distance measurement, select a clustering procedure, decide on the number of clusters, that's the K value, then interpret and profile clusters, access the validity of clustering. This is the some conducting cluster analysis process. The first we see the formulating the problem. Most important is selecting the variables on which clustering is based. Inclusion of even one or two irrelevant variables may distort a clustering solutions. The variables selected should describe the similarity between objects in terms that are relevant to the marketing research problems. So mostly the clustering used for the marketing research problems, the marketing data analysis, should be selected based on the past research, theory or consideration of the hypothesis being tested. Select a similarity measures. The first one, similarity measures handle correlations or distance. The second step, The most commonly used measures of similarity is the Euclidean distance. The Euclidean distance is mostly used for the k-means algorithms. The city blocks distance is also used. The third step, if variables are measured in the vastly different units, we must standardize data, also eliminate outliers. Use of different similarity or distance measures may lead to different clustering results. The final, hence it is advisable to use different measures and compare the result. This is the select similarity measurement. Then, classification of clustering procedures. The clustering procedures commonly classified in two ways. One is the hierarchical clustering and also non-hierarchical clustering. The hierarchical clustering is the agglomerative devices. In agglomerative again classified the three categories. First was the linkage methods, then variance method. The last method is the centroid methods. So linkage methods also again classified the three types. One is the single linkage, complete linkage, average linkage. This is based on the cluster distance. Then variance methods is the horse method. Non-hierarchical also have three types. The one is the sequential threshold, another is the parallel, the last one is the optimizing partitionings. So it's the types of clustering procedures. First, we see the hierarchical clustering methods. Hierarchical clustering is a characteristics by the development of a hierarchy or tree-like structures. It is the tree-based graph structure. Agglomerative clustering starts with each object in a separate clusters. Clusters are formed by grouping of objects into bigger and bigger clusters. So this type of clustering data is the agglomerative clusterings. Divisive clustering means it starts with all the objects grouped in a single clusters. So clusters are divided or split until each object is in a separate cluster. This is the difference between the agglomerative clustering and the divisive clusterings. Then agglomerative methods are commonly used in the marketing research. They consist of linkage methods, variance methods and the centroid methods. Next, the hierarchical agglomerative clustering. The first type is the linkage method. It's the three types. Already we discussed the types of clusterings. In single linkage method is based on minimum distance or the nearest neighbor rules. So the single linkage means the distance between the nearest cluster is the very minimum, very small. Then the complete linkage method is based on the maximum distance or the furthest neighbor approaches. The last type is the average linkage method. The distance between two clusters is defined as the average of the distance between all pairs of objects. So these categories depend on the distance of the clusters. So the minimum distance means it's the single linkage. The distance is maximum and that's the complete linkage. Then you find the average of the distance between the all pair of objects means the average linkage methods. Next is on diagram representation for the linkage methods of clusterings. The first one is the single linkage. It is the minimum distance of the clusters. The cluster we have two set of clusters, cluster 1 and the cluster 2. Here we find the some distance, the nearest. So the distance is the minimum, it's the single linkage. The second type, the complete linkage, the distance is maximum, increase means the second type. Then we find the average linkage means we will measure the average distance between the all pair of objects. Okay, that's the average linkage method. Then hierarchical agglomerative clustering, variance and centroid methods. The variance methods generate cluster to minimize the within cluster variance. That's the variance type. In the centroid methods, the distance between two clusters is the distance between their centroids. That's the means for all the variables. The Ward's procedure is commonly used. For each cluster, the sum of the squares is calculated. The two clusters with the smallest increase in the overall sum of squares within the cluster distance are combined in the Ward's procedure. It is mostly used in the clustering algorithms. Here, it is of the hierarchical methods. Average, linkage and Ward's methods have been shown to perform better than the other procedures. So, we mostly used the Ward's method and the linkage methods in the clusterings. Then other agglomerative clustering methods, that's the Ward's procedure and the centroid methods. The difference between these two types of clustering methods. Centroid method means we can consider the center cluster values here. Next one, the non-hierarchical clustering methods. The non-hierarchical clustering methods are frequently referred to as k-means clusterings. So it is also have a three types. In the sequential threshold method, a cluster center is selected on all objects within a pre-specified threshold value from the centers or grouped together. It is the sequential threshold method. The second is the parallel threshold method. Here, several cluster centers are selected and objects within the threshold level are grouped with the nearest centers. This is the main difference between sequential and parallel. The last one is the optimizing partitioning method. Is different from the two threshold procedures in the objects can later be reassigned to cluster to optimize an overall Cartesian, such as average within the cluster distance for a given number of clusters. Then some idea behind the k-means. In the algorithm for k-mean clustering, partition items into k clusters, assign item to cluster within the nearest centroid mean value, recalculate centroids both of cluster receiving and losing items. The next, we repeat the steps 2 and 3 till no more reassignments. So when we will stop the procedure means we get the same new centroid value and we will stop the procedure. Next, select a clustering procedure. The hierarchical and non-hierarchical method should be used in the tandem. First, initially clustering solution is obtained using hierarchical procedure, that the Ward's methods. The number of clusters and cluster centroids obtained are used as an input to the optimizing partitioning methods. Next, choice of clustering method and choice of distance measure are interrelated. For example, squared equivalent distance should be used with the Ward's method and also the centroid methods. Then several non-hierarchical procedures also use squared equivalent distance. Next, decide number of clusters. In theoretical, constitutional or practical considerations, we decide the number of clusters. In hierarchical clustering, the distance at which clusters are combined. Then non-hierarchical clustering, the ratio of the total within group of variance to between group variance can be plotted against the number of clusters. Then stop when similarity measures value makes sudden jumps between the steps. Next, interpreting and profiling clusters. Here involves the examining the cluster centroids. The centroids enable us to describe each cluster by assigning it a name or labels. The profile the clusters in terms of variables that were not used for clusterings. This may include a demographic, product usage, media usage, and other variables. Thank you.